Nuts. A tough topic to crack. Steel forgings. Heavy metal without the electric guitars. And skateboards. We'll roll through the manufacturing process. Ceramic tiles are a popular choice for flooring, kitchen backsplashes, and bathroom walls. They can withstand humidity and won't absorb liquids or odors. They're also fireproof, fade-resistant, and stain-resistant. And no matter how much you walk on them, ceramic tiles never wear out. This factory specializes in wall tiles. Floor tiles are made using the same process, but a different composition of ingredients. The starting ingredient here is talc, a soft, powdery mineral. They blend it with 4 different powdered chemicals, the names of which are a company secret. The ingredients go into a mixer, where they're hydrated until they're 6% water to 94% powder. The mixer runs for precisely 12 minutes. Any longer would heat the mixture and dry it out. The mixture is now slightly damp and quite lumpy. A conveyor belt transports it to a grinder that mills it to a fine texture. This mixture is now ready to be formed into various models of tiles. The factory uses fully automated machinery to produce its 10.8 centimeter square tiles, a standard wall tile size. A moving tray first deposits a batch of mixture into a mold. The mold's cavity is in the shape of 6 upside-down tiles. A press descends, applying both heat and pressure. This compacts the mixture into the cavity, solidifying the shape. As the press rises, the mold automatically pops out the tiles. They roll off the machine onto a conveyor belt. The belt now flips the tiles right side up without breaking them, which is quite a feat considering that these yet-to-be-baked tiles aren't fully hardened. The equipment is precision adjusted to handle the tiles gently at all production phases. A revolving brush now sweeps the tiles clean. Their surface must be free of dust and other contaminants for paint to adhere properly. The factory uses a water-based paint that's specifically designed for ceramics. It continually circulates in the vat, keeping the color well blended. The painting process resembles an automatic car wash. The tiles travel through 4 spray zones, each of which applies a thin coat of paint. Then they pass under powerful heating elements, which dry the paint in mere seconds. All that's left is to bake the tiles, which we'll see shortly. The factory uses the same ceramic mixture to produce these square border tiles. They look just like the other wall tiles, except that 2 of the sides are rounded. When you install a row of these border tiles above the regular tiles, the rounded edges produce a clean, finished look. While the factory uses the same painting process for border tiles, the molding process, as you just saw, is somewhat different. Rather than being fully automated, it requires some manual labor due to the tile's complex shape. That's why border tiles are often more expensive than regular tiles. When the tiles come out of the dryer, workers stack them on wooden racks. They load the racks onto mobile carts, then roll the carts into a gas-powered oven called a kiln. This factory's kiln is 58 meters in length, longer than an Olympic-sized swimming pool, and large enough to bake some 50,000 wall tiles in one shot. The firing, as it's called, takes 14 hours. Any sudden changes in temperature could produce thermal shock and crack the tiles, so it starts out at 200 degrees Celsius, climbing gradually to a peak of 1,075 degrees, then descending slowly back to the starting temperature. After a cooling period that lasts roughly an hour, the tiles come out. They're now fully hardened and ready to have their back to the wall. Scan the snack food aisle of your local supermarket, and you'll notice that barbecue, ketchup, and salt and vinegar flavors are no longer limited to potato chips. Nuts come in tantalizing taste choices too, but if you're a traditionalist, you can still buy them plain, salted or unsalted. The botanical definition of a nut is a dry one-seed fruit in a hard shell that doesn't open on its own. Most peanuts have 2 seeds, so even though we call them nuts, they're technically a legume, a type of pea actually. One way to prepare peanuts for sale is to roast them whole right in their shells. This is known as dry roasting because they cook the peanuts without using any oil in a large convection oven. The oven temperature is 149 degrees Celsius. The roasting process takes about a half hour. When the peanuts come out, they're fully cooked and ready to be cracked open and eaten. Before the peanuts go off to be packaged, a worker inspects them, removing any shell fragments and foreign matter. Another way to prepare peanuts or other nuts for sale is to dry roast only the seeds. These peanut seeds arrive at the factory with their shells and skins already removed. A conveyor transports them to a revolving drum called the tumbler. As the tumbler spins, the nuts are sprayed with a liquid seasoning mixture, one of 10 flavors this company produces, such as salted, smoked, ketchup, barbecue, and salt and vinegar. The rotating action ensures the seasoning coats the nuts thoroughly. Now a conveyor transports the peanuts to a convection oven. The conveyor turns from side to side, spreading the peanuts in a thin layer so that they'll dry roast evenly. They roast for the same length of time and at the same temperature as peanuts in the shell, about a half hour at 149 degrees Celsius. As they exit the oven, a worker breaks up any clumps. They tumble on the seasoning after cooking when they use the other method of preparing shelled nuts. Instead of dry roasting the nuts as we saw earlier, they fry them in oil. This process is called oil roasting. It gives the nuts a greasier fried taste. These cashews are on their way to be oil roasted. They go into a huge frying tank containing 2,200 liters of canola oil, heated to 160 degrees Celsius. When the nuts come out fully cooked 15 minutes later, they're steaming hot. A powerful ventilation system draws the heat outdoors, cooling the cashews to room temperature. This takes about 15 minutes. By now, the nuts have absorbed any cooking oil that remained on their surface, so they receive a light spray of vegetable oil. This makes their surface sticky again, so that salt or seasoning mix will adhere. This factory also produces nut mixes. Here, the mixer is combining various nuts with dried fruit. From there, it's onto a packaging machine whose 8 computer-programmed scales automatically weigh out a specific package portion. But before each portion goes into a bag, it passes through a metal detector. This ensures that no shards of metal have worn off the equipment and fallen into the food. The machinery hermetically seals the plastic packages, This keeps the contents fresh for at least 6 months. When does forging not involve fraud? When you're talking about metal. Many industrial machines contain steel parts that have to withstand great stress. The metalworking method that produces the strongest steel parts is forging, heating the metal, then forming it to the required size and shape. Steel forgings are made from scrap iron, pieces of used iron recovered from demolished buildings and old cars, as well as bits of new iron left over from the manufacture of iron products. Forge workers maneuver a gigantic magnet to lift 5 tons of scrap at a time until they've filled a 25-ton scrap bucket. The bucket empties 2 such loads into a fiery furnace whose temperature peaks at 1650 degrees Celsius. This is called an electric arc furnace because the heat's created by a strong electric current running in an arc between 3 electrodes. There are about 20 main grades and 100 subgrades of steel. They're produced by adding specific metals or non-metallic chemical elements such as aluminum, nickel, chromium, vanadium, manganese, carbon, and molybdenum. They also add the mineral fluorite to help fuse the metals, some of which are in the form of blocks called ingots. Throughout the 3.5-hour meltdown, they test and adjust the chemical composition. They try to attain the lowest hydrogen, oxygen, nitrogen, and sulfur levels, the key to producing strong, high-quality steel. Then they pour the sizzling molten metal into a 45-ton ladle that's lined with heat-resistant brick. They add aluminum and lime to chemically counteract oxidization, rusting caused by air exposure. Now they cast an ingot, a block of steel that they'll shape into a forging. The molten metal flows out the bottom of the ladle into a mold below. This bottom pouring, as it's called, makes for a smoother casting because liquid flowing downward doesn't swill around as much as liquid poured sideways. This forge can cast ingots weighing up to 42 tons. After several hours, the ingot solidifies and they turn the mold upside down to extract it. Then, over 12 hours, they reheat the ingot to 1200 degrees Celsius. This makes it soft enough to hammer or press into shape. To make large forgings, they use a machine called a forging press. Mounted inside is a forming die or pair of dies, depending on the technique they're using. The press applies thousands of tons of pressure, crushing the ingot and forcing it against the die. The steel, meanwhile, is quickly oxidizing with all this air exposure. They use a high-pressure water gun to remove the scales of rust. An ingot often passes through a die several times, or through a series of dies arranged in sequence. Each pressing forms the metal bit by bit into the final shape. Metal is composed of microscopic crystals. Squeezing it in a press bends these crystals, destabilizing the metal structure. But reheating the metal creates new crystals to replace the deformed ones. This restabilizes the structure, and because the new crystals are smaller, makes the metal stronger than before. That's why finished forgings require heat treatment in what's called an annealing furnace. They heat for a day or two depending on the grade of steel. Then they soak in a water and chemical bath for about 5 hours. This strengthens the steel even more. Finally, workers mount the steel forgings on lathes and milling machines. They remove the rust scales that form during heat treatment, then precision machine the forgings into what the client ordered, usually industrial parts such as rotors, spindles, and shafts. Many factories prefer to buy forgings in the shape of blocks or bars and machine the parts themselves. Skateboarding may have started out as a simple outdoor pastime, but in the decades since, it's evolved into a popular thrill sport. Professional skateboarders are known for performing spectacular aerial maneuvers, achieving speeds and heights the early skateboarders could never even have imagined. In the 1930s, thrill-seeking kids began attaching their metal roller skate wheels to wooden crates. Little did they know this would one day spawn a worldwide phenomenon. The boxes evolved to boards in 1958, when some California surfers invented sidewalk surfing, something to do when bad weather prevented them from riding the waves. They attached roller skate wheels to wooden planks, then coasted through the streets. Pretty soon the fad caught on in cities throughout the United States. The deck, the part of the skateboard you stand on, is made up of several thin sheets of wood, called veneers. Inexpensive boards use fewer sheets and lesser quality woods. These high-end boards use a full 7 sheets of top-quality maple. Only the top and bottom veneer sheets will actually show, so their exposed side is sanded smooth, and the other side gets a coat of glue. The inside sheets, meanwhile, go through the glue spreader, which saturates both sides. This adhesive is specially formulated to withstand vibration and shock. Workers stack 35 sheets of veneer, the equivalent of 5 skateboard decks, and place them in a mold. Skateboards vary in size and shape, so there's a different mold for each model. A press applies 40 tons of pressure, compacting the sheets and bending them to the shape of the mold. Excess glue squeezes out the sides, bonding the 5 decks into one block. They'll be separated later. The block comes out after 3 hours. Now they drill 2 sets of holes through the block. These are for mounting the front and back trucks, the pivoting metal axles that enable the skateboard to turn. Now it's time to give the rectangular block a skateboard contour. They select a template in the general shape of the model they're making. It has pins underneath that fit snugly in the truck holes they just drilled. This holds the template still while they do what's called the rough cut, sawing around the template, leaving a 2.5 centimeter margin. Cutting off the excess separates the 5 decks. Now they contour each deck individually. Using a precise template this time, they run the deck against a cutting blade until they have the final shape. Using a router now, they round off the top and bottom edges. Then they smooth all the surfaces against a drum sander. Now they switch to a buffer, which uses a combination of brushes and fine grit sandpaper to remove any rough wood fibers. The deck is now perfectly smooth. The next stop is the finishing room, where they first spray the decks with a colorless primer. This seals the pores in the wood veneer so they won't absorb the coat of lacquer that comes next. The primer takes 2 hours to dry. Next, they spray on a coat of clear or colored lacquer. It leaves a protective, high-gloss finish. The lacquer also takes 2 hours to dry. The final step of the finishing process is applying the decoration. The bold graphic designs are printed on plastic sheets. The skateboard factory either buys them ready-made or produces them in-house using its own silkscreen printing equipment. Workers center the design sheet, then feed the deck through a machine that applies heat and slight pressure simultaneously. The heat, 200 degrees Celsius, induces a chemical reaction that melds the ink and lacquer. When the plastic comes off, the deck is finished. Decks of this caliber are sold unassembled in specialty stores. They're designed for serious riders who want to customize their skateboards. They pick and choose from different types of trucks, wheels, bearings, even the bolts that hold everything together. All these factors determine how fast or how fancy their skateboard will move and maneuver.